So what we see is our stress Z is equal to 0. Normal stress Y is also equal to 0. Okay. So if I were to call this our point X, this will be our point Z, and this surface will be our point Y. So I say this is just a sketch, okay? So we are trying to find out whether are we going to use this formula over here or this formula over here. So now we do a sketch. We do a sketch now. So we're going to sketch a mole circle. So normal stress, shear stress, clockwise, anti-clockwise. Okay. So we know that over here, our line, this is our stress Y and stress Z line. Okay. And we know that stress X is in compression. So if we have a shear, okay, so this is, for example, our shear line. Okay. Over here is our shear line. Okay, that's our shear line. So we know that point Y will have 0 normal stress and 0 shearing stress. Eugene, come on. So this is our 0. This is our point Y. Okay. Then point X is over here. And point Z is on 0 normal stress line, but the shearing stress is of point Z. So we construct mole circle now. Okay. So this is our first mole circle. So this circle belongs to our XZ plane. And our XZ plane, as you can see, is our in plane. Okay. Because this surface over here, I'll use a different color. This surface over here is our XZ plane, the biggest face one. Okay. And then we can draw another circle. Over here. And this circle belongs to our YZ plane. And YZ plane is our out of plane. Okay. And finally, our last circle over here. This is our XY plane. Again, this is our out plane. So what you realize down here is you have your stress mean over here, and you have stress max over here, right? So which formula you have to apply is you have to apply by looking at your 3D mole circle. You have to apply this value over here because stress max and stress mean are either positive or negative. That is one of the conditions, right? Whereas the one on top is where stress mean is equal to what? 0. For our case, it's not. This is where you have to construct 3D mole circle. Okay, you cannot just use the first one and then go for it. You can't do that. Okay. So up to now, it is the analysis. Okay, that is your value. The analysis is the difficult part. Once you clear the analysis, the rest is just putting in formulas. Okay, it's just putting formulas. Okay. So now we are going to put in the formula. So now from here, where do we go from here? We have to determine stress max and stress mean. And we know that the in-plane one is the important one. Okay, the out-plane one, the inner circles one, they are not critical. Okay. So now, so if the in-plane one is the most critical one, we can just apply what? We can just from here apply 2D mole circle, right? Okay, right? We just need to find the XY plane one. So I'm going to copy this circle. I'm going to go to the next page. Okay, so we are going to determine our stress max and our stress mean. Okay, before we do that, okay, so I'm also going to copy our element. Our element is important. Without the element, we can't do anything. I just want to copy the element, you cheeky sort. Okay. So now we want to find what is our stress X. Okay. So we are going to find stress X due to axial load. Okay. So stress X is equal to minus. Okay, I will take the other diagram also. My apologies. Hey, come on, Eugene. Okay, it's equal to minus 2500 divided by pi c squared. Okay, so c is the radius of the shaft. Okay. Then we are also going to find stress X due to bending moment. So all these are in fact this question is easier than what we used to do. Remember, what we used to do is just we are given forces, then we have to identify what is a bending moment, what is a shear force, and what is the torque. This one is all given. Okay, the only difficult part, not difficult, the only part that we have to know is Tresca. Okay, so we have stress X is equal to, because it's compression minus the bending moment is 1500 multiplied by 12, right? Multiplied by c, which is the radius, over pi over 4 c to the power 4. Okay. So over here, we can cancel the cube. So this will be equal to 1500 multiplied by 12 divided by 4. 1500 multiplied by 12 times by 4, not divided. 70 minus 72,000 over pi c cube. Yes, I did. Okay, Jihan asked, yeah, multiply by 12 is to get into inches. Yes, you are right. Okay, so from here, we know that stress X is equal to minus 2500 over pi c squared. Okay, and then minus 22,000 over pi c cube. Right. Then next, we're going to find due to the torque. Or the shear. So this equation is important. Okay. So the shear due to the torque. So the shear is equal to the torque. We are looking at 2300 multiplied by 12. Multiplied by C. Then we divide by 2. Then pi over 4 C4. So this will be equal to, so this and this cancel is 2. So 2300 times 12 times 2 is equal to 55200 divided by pi c cube. Okay. So if now I were to construct the element in 2D, okay, we have our compression. Okay, so this is our X. Let me look at our orientation. I do apologize. There's our X. Okay, so this is our X. And coming down, because we did it, this is our Z. So this is our shear. So from here, we know that our stress X, right? We know that our stress X is equal to minus 2500 over pi c squared minus by 72123 over pi c cube. And our shear is equal to 55200 over pi c cube. Okay. So from here, we can find the center of the circle. Okay. Which is our stress average. And this is equal to stress X plus by stress Z divided by 2. Okay. So our stress average will be equal to minus 2500 over pi c squared minus by 72123 over pi c cube. Right? You close the whole bracket, then you divide by whole thing by 2. I'm going to make things simple for me later on during the calculation. So I'm going to have a common denominator to be minus 2500C minus by 72,000 divided by pi or 2 pi C cube. Okay. So what I've just done is I make the common denominator to be pi C cube. So now we have the stress average. So let me bring the circle. Hold on, I'll go back to that. My apologies. Okay, so I'm going to get rid of this circle over here. It will be clearer. Okay. So we have identified. Okay, we have identified our average stress.